everyone, this is Miss Moriarty and I'm here to discuss with us topic 1.7, which is all about the hydrologic or water cycle. So now in our discussions of Unit 1, we're now going to get into a lot about the abiotic factors, things like water, carbon, nitrogen, and so on, and how those cycle through ecosystems, and how living organisms depend upon those things. So looking at our water cycle and what kind of drives the movement of water on Earth, that's usually going to be the energy from the sun is going to help to drive the water cycle. Some terminology that we need to know as it relates to our biogeochemical cycles and the water cycle is going to be what's known as a source or a sink. Since water can move in different types of states, right? It could be a liquid, could be a gas, could be a solid. There's going to be certain parts of the water cycle in where we see water being released, as well as water being then stored for longer periods of time. So that's going to be your difference between a source and a sink, right? A source is going to be releasing, right, water, while a sink is going to be storing it. Now, looking at the water cycle specifically, our oceans are going to be our greatest water reservoirs on Earth. Our ice caps and groundwater are more of our smaller type reservoirs. They contain our fresh water, and unfortunately, out of all the water that we find on Earth, really only about 3% or so is fresh water, and only about even 1% of that is actually usable fresh water for us to use for drinking purposes, cleaning purposes, and so on. So it's really important to kind of understand how water moves throughout Earth, especially if it's going to be a resource that we use heavily. So how does water cycle on Earth? There's going to be two main sources of water. We can see transpiration. This is a process that is used by plants to actually draw groundwater, right? So they take in water against gravity, right, through their roots up through their leaves. That water eventually leaves through the opening of the leaf, right, through the stomata. You might remember some of this back from biology in freshman year. That movement of then water, right, leaving out of the stomata is actually what then brings all of that water up through its roots. We can also see a lot of water leave from surface waters like oceans, lakes, ponds, and streams. Both of these processes are going to be driven by the energy from the sun. So we see water can be released through evaporation on surfaces, as well as specifically transpiration from the surface of leaves. Now, what happens, right, when we know water is going to evaporate, turn from a liquid, right, to eventually a gas, and go up into our atmosphere? Well, eventually that water is going to condense and cool and form precipitation or rain. So how that water returns to Earth is going to be through rain in either the form of, right, rain or snow or hail. When that precipitation then flows over Earth's surface, it can go many different ways, right? It can wind up along the surface in, let's say, oceans, lakes, ponds, and streams, but it can also trickle down into the soil through infiltration and then be trapped underwater in what's known as a groundwater aquifer. So that precipitation can help to then recharge any groundwater, right, through any permeable type surface. So that's going to be soil that's going to allow that water to travel through. Runoff can also recharge any other surface waters. But the issue with that is as that water hits Earth's surface, and let's say it travels into a river, stream, or lake, it may carry pollutants and other things that are found on Earth's surface into that waterway. So kind of putting it all together, looking at our water cycle, remember what helps to drive the water cycle is the solar heating, right, from the sun. We can see evaporation from any type of surface water or just surface from the earth. We could see transpiration, which is evaporation from plants. We know that that's going to wind up right in the atmosphere. Eventually, over time, that we're going to see condensation, right, that liquid now turning that water vapor turning back into liquid, right, returning back to earth. Plants can then take that water back up through their roots and start the cycle all over again. Some of that water can hit earth's surface, go through runoff into any land surfaces, or it can infiltrate into soils and eventually be trapped underground in groundwater aquifers. All right, here is our practice FRQ. So examining the model here to the right, if most of the trees in an area were removed due to deforestation and a paved area was created, identify one process that would decrease and two processes that would likely increase, and explain why these changes would occur. So take a moment, right, pause this video, answer this in your practice FRQ sheet and in the Edpuzzle. Okay, at this point, right, we should have answered our practice FRQ on your sheet as well as in the Edpuzzle. So one process here that would decrease due to deforestation would certainly be transpiration, right, since we said that this is going to be evaporation specifically from plants or trees. Now, some things that may increase, right, due to now putting a paved area in this way could be evaporation, because now there's decreased shade, right? With decreased shade comes a lot more heat, a lot more evaporation happening. We may also see an increase in surface flow or runoff, because now when we put down pavement, that is no longer a permeable surface. So now we're going to see probably a lot more flooding, a lot more surface runoff, because that water can't infiltrate the pavement. All right, everyone, that's it for our video on 1.7. If you have any questions, please leave them at the end of the video.